Hi. Can you hear me okay, Doran? Okay. As long as I don't smack that too hard. I want to talk about website performance. And first question that at least some developers ask is, why should I care? And some of these reasons are pretty well known or obvious. Some of them less so. Better user experience is pretty obvious. But a follow-up to that is that Yahoo and a couple of other large companies did studies a few years back that showed that e-commerce visitors convert at a higher rate on sites that are faster. And it was something like 0.1% higher conversion rate for every 100 milliseconds of time saved, which is surprisingly a big difference, I thought. Mobile networks are getting used more commonly, and they have, even if the speeds are pretty good, the latencies are worse than people are used to at home. And so the more round trips you got to make to download files, the slower it's going to be. Bandwidth does cost something, especially if you're pushing a lot of traffic. And then a couple of years ago, Google announced that they were going to start considering performance in their rankings. I don't think it's a major consideration, but every little bit helps. And before I go too much farther, I wanted to ask, how many in here are mostly interested in front-side performance tuning? Raise your hand. How about backside app server type stuff? And database? So kind of spread out everywhere. A few other reasons. I think I said reduce bandwidth costs on the other one, but that's so important we'll put it twice. Not having to get more servers or not having to scale out at all beyond a single server is a nice thing to do if you can manage it. Reducing CPU load on I/O gives you more headroom on your machines, and even dumb reasons like if you're logging everything, having smaller logs is kind of nice. A few things that I think are worth keeping in mind. Some optimizations are neutral, some can actually make you have a better architecture, and some make a mess out of things and are better to avoid until you really need them. So, no matter whether you're talking about the browser or the web server or the app server or the database, some general principles are that reusing some piece of data wherever you already have it is faster than not reusing it. Doing less is faster than doing more, and doing nothing at all always wins. So if you can, do nothing at all. It sounds really obvious, but sometimes there's a place where we can spend a lot of time optimizing something, and if we think our way through it, we can figure out a way to not do that thing at all. In measuring website speed at the front end, the things you want to look for are the first load time when the cache is empty or cold. And you want to look at both load time and the number of bytes that come down. The number of bytes is of interest, especially if you're on mobile networks, smaller DSL lines, things like that, and for your bandwidth measurements. But absolute time is probably what matters more to the end user, so they're both worth considering. And then on the same browser, if you just visit the same page again, that's a reload, and that's with the cache already warmed up with the assets that were needed, and you want to measure that speed too. Sometimes that's the easiest thing to speed up, and if you have people staying on your site a long time, that can be worth quite a bit. So, before we go too much farther, I want to look at an example. And who's heard of webpagetest.org? Hands? Really? Nobody? That's one. Okay, that's awesome, because it's a pretty cool thing. So it's a free service that you can use on the web, and there's a bunch of reasons I like it. Number one, it will do tests with Internet Explorer, so I don't have to. That makes life easy. It lets you choose the version, i.e. 6, 7, 8, 9. You can choose the place in the world that it does the test from. Defaults to Virginia, but it will do it from Europe or Asia or the West Coast, wherever. It will do tests from Chrome. I actually don't remember if it does Firefox. If somebody looks and you find out, let me know. But I usually do IE exactly because I don't use IE myself, and so it's good to see things through that lens. And this is a test result that was run from Dulles, Virginia on IE7. Oh, it also lets you choose the speed of the connection that it's using, and it simulates different round-trip times for latency and different bandwidth. This one is a FiOS test. And this is a site called 479popcorn.com, and you can see the first view, the total load time was 4 1/8 seconds, and the total number of bytes that were downloaded was 201K. And basically it does that, it records everything that's going on, and then it creates a waterfall view that shows you all of the mostly images, but also CSS and JavaScript that were loaded, and when each of those happened from the moment the test started. It also looks at first byte time, which is useful. That's the time from when the request starts till the first byte started streaming to the browser. So that's mostly measuring initial latency of establishing the connection and DNS resolution. And then basically it just loads the same page again. That's the repeat view. And here that was a little over 3 seconds, and 30K bytes came in. So the after version of this, well, actually, let's look at the waterfall view in more detail first. So if you zoom in on the waterfall view, it shows you every object and then where they came in. And you can see occasional anomalies like, why did that one take so long? It will give you more detail if you scroll down and show you how many bytes were involved, where it came from. It checks out, based on IP address, the physical location, which is approximate but useful to know. And it can also be really helpful because it can point out to you that, for example, Google Analytics may be the slowest thing on your page, or it may actually be faster than you thought. You may be using some tracking, pixel somewhere, and obviously there's not a lot of data coming out of a 1-pixel GIF, but for some reason it could be really slow. And so this is a good way to check that out. So back to the times here. So you see 4.125 seconds first view, 3.029 repeat view. This is going to be the after I did some of the things I'm going to talk about. We got the first view down to 1.8 seconds and the repeat view to 0.9 seconds. And most happily, the repeat view's number of bytes downloaded was just 6K. So that's kind of what, on front-end optimization, the kind of improvements that I'm angling for. So, I already talked about the stack. Let's look at the browser layer specifically. We have JavaScript, both your own code and libraries that someone else wrote, images, fonts, CSS, and HTML. A lot of people are starting to use web fonts now, and that's adding somewhere between 20 and 50 or more K to a page that they may not have thought a lot about because it's beautiful, but should be considered. So, the ideal goal is to instruct the browser that it can cache assets that have already been downloaded. That won't help you any with the initial download, but if you have window dressing on your site that's the same on most pages, it's great if the browser can assume that that's still good and doesn't have to ask about it at all. Normally the browser will do a conditional get. It'll present either the E tag or the last time of modification to the server and say, hey, has this changed? And the server will respond back and say, no, it's the same. And it doesn't have to re-download it. That's a great optimization, but it's still a round trip, and it's much better to avoid that. And the reason I call this full page caching is ultimately it's best if you can do that with the whole page, including the actual HTML file. And almost every project is going to say, no, we can't do that. We have dynamic stuff. And a lot of times that's true, but it's worth trying to ask the question to see if you can pull it off. Because if you can, it means that the same user browsing on your site for some period of time, coming back to a page they've been to, gets an absolutely instant response with possibly 0 HTTP connections. In reality, you probably have some analytics like Omniture Site Catalyst or Google Analytics, and that's going to hit the server every time, but it's going to be pretty fast anyway. And it's their problem to scale their stuff, not yours, so that's nice. So, how can you have a fully cached page but still have some dynamic content? Well, some of the stuff's fairly easy. If you're an e-commerce site, for example, and you want to show somebody that they're logged in, and that's all that you're customizing on that page, well, you might as well put that in a cookie or in HTML5 local storage, and the page can be 100% cached and identical for all users, but you're using JavaScript to tell them, welcome back, John, we're so glad to see you again. Same for login state. You probably want to talk to your server to see if these credentials they present are valid, but once they're logged in, you might as well set a cookie that says, yes, they're really logged in. And if you use a cryptographic hash to hash together their username and a secret that only the server knows, you can later compare the hash to see if they're really logged in when you need to know. But if they're fooling themselves to say, I'm logged in, what do you care, right? It doesn't matter. So there's really not a security problem. Same thing with items in the shopping cart. You can store the number. They have 5 items in their cart. You could actually store the items themselves. Most of the time, that doesn't take a lot of space. And that makes it possible not just to have the page fully cached, but to have that one cache object be used for every one of your visitors, which is nice. If you can't pull that off, try caching pages 100% for unauthenticated users. And if you set a login cookie, then that effectively is a cache buster. And for people who are logged in, if you have highly customized displays, then great, go ahead and drive them through to your app server. But if a lot of your traffic is unauthenticated people coming in, or if some of the authenticated users are visiting pages that don't vary, you can still have those be cached entirely. I started talking about this first because there are a ton of things that you can optimize. But think about it. If you can manage to make your pages be fully cached at the edge of your network, and you never touch the regular web server, you never touch the app server, you never touch the database server, you don't have to optimize any of those. You don't increase the bugginess. You don't have multiple layers where you can have different ages of caches. So it's just a much easier way to go. Admittedly, it is the hardest place to do it. But in a new project, if you work on that from the get-go, it may be easier than you think. And even in some old projects, what if you can only cache the home page 100%? Well, that's what a lot of people are going to by default. So that's worth doing. Another thing you can do, if part of your page needs to be dynamic, but most of it is the same, you could have that one part be served through AJAX if you're counting on people's browsers being new enough to do that. And nowadays that's pretty common. If you have a bunch of components in AJAX, you may end up slowing your page down, so you want to benchmark, but it's probably faster to serve a little bit of data in JSON and render it in the page with JavaScript and everything else is cached than to go through the entire app server database and all that stack just to serve that one piece. Another thing that's nice to do, webpagetest.org won't show you this because they start with an empty cache at every test. But normal users have probably been browsing the web a lot. And so if they are using some objects that are hosted on popular CDNs like Google's for jQuery, then your users may already have that cached if you point to the same resource. Hosting jQuery yourself is nice because you can control it, but in reality, most of the time that doesn't matter. And if you point to the very specific version on Google's servers, that's always going to be what it is. So you can offload that, and if people are coming to your site with a partially pre-warmed cache, that can be nice. And like I said on something else, you don't have to worry about helping to pay for the bandwidth or scale that, which is a bonus. Okay, if you do need to serve certain data yourself, then a popular thing to do is to combine the assets. If you have 6 or 7 CSS files it may be best to combine them into one. It's bigger, but it's a single request. It's a single cache object to worry about. I don't think this should be taken to extremes. I mean, if there's certain CSS that's only used in one place on the site and it's big and complex, maybe it's not worth it. But a lot of sites can get from dozens of CSS files, if they're designed naively, down to 1 or 2 or 3, and that reduces the number of requests. Who's heard of image spriting? So image spriting is taking a bunch of images that are of a similar type and putting them in the same file next to each other, one big file, and then using CSS to offset a display window. It has the same advantage that you don't have a lot of round-trip requests. You do need to be careful if you're using JPEGs. JPEGs are lossy. The edges of the things you're stitching together may bleed between each other and look kind of weird. If there are a bunch of photographs of similar backgrounds, then they're probably fine. PNGs or GIFs should always be fine because they're not lossy on the edges, assuming your image program didn't mess them up. And then you have to watch out for some goofy situations, like if you have a bunch of portraits of people lined up in a rectangle, you could have a big empty chunk at the bottom, and with JPEG that won't compress particularly well. So you may want to consider having a really long image with the portraits. It's worth experimenting a little bit with spriting. Spritebox.net is a site that will take a pre-combined image and help you output the CSS for that, and I'm sure there are a lot of others. Then there's optimizing the assets. There's the obvious long-time need to compress the images. With a JPEG, maybe your standard is to compress it to a particular compression level, but if you take a minute to experiment with it in real time, you may find you can compress certain images more highly than others, shave off some space, and on a popular page that can be worth it. On an unpopular page, it's probably not. Many images have metadata that they don't need, EXIF information from a digital camera or embedded thumbnails. You want to strip that stuff off. Good image editors can do that, but you just have to pay attention. If you're doing screenshots or anything computer generated that has hard lines, hard edges, PNG may be a better compression format for that. Aside from looking better, it may take less space, so it's worth experimenting. And then there's the popular technique of minifying, which is turning your JavaScript or CSS into highly compressed garbage code with weird names. Of course, you want to keep your originals around. Yes?
There's a great new site out called jpegmini.com. And I've used a lot of JPEG compressors, but there's something magical about that one.
jpegmini.com, huh?
Yeah. We serve gigs of product images and
cool.
Something they've been able to do that others haven't.
Nice. Thanks. Well, I will check that out anyway. I won't speak for everyone else. But, minifying, it's fine. I think it's kind of nice to use a .min.js file name and keep the original around even for yourself so you can find it. You're not going to actually hide what you're doing from anyone, so there's really no reason to not make accessible the original. But minifying's nice for your average user that isn't looking at the source. All right, CDN stands for Content Distribution Network. There are a lot of services for doing this. Akamai is probably one of the oldest and most popular and fastest and expensivest. And it's good stuff. If you have the money for it, if the project you're working on has a good budget, you should probably just use that. In a lot of cases, it's really good. One of the things that's really neat about a good CDN like Akamai is it isn't just about caching and offloading traffic from your site. They have servers all around the world that cache the data and serve it to the people network nearest that server. And I had to get schooled by one of our clients once. I thought there was no possible way that would be anything but a little bit slower than hitting the origin directly if the cache was empty. And he did some tests and found out that actually with Akamai, their network connectivity is so good that in a lot of cases it is faster to go through Akamai to the origin, even when their cache is empty, than to go direct. So seeing was believing on that one, and it's a good thing to know. Again, if you have the money for the project, that can be a good thing. Another way to go about it is to just make your own mini CDN, probably without the geographic distribution. But Varnish is a very fast HTTP accelerator reverse cache proxy that's good for that. Nginx is a web server that is so fast that it's really in that same class. And some of the good things you can do with this, if you use a subdomain, for example, just to serve your static assets like your images and JavaScript and CSS and fonts and whatever, then that subdomain won't have any cookies, so your browser isn't wasting any time or data sending cookies out to this server that is not going to use them because it's only serving static assets. So that's an advantage. You can do that anyway, with or without a CDN, of course. And then using a subdomain is also nice because browsers, I believe now all of the common browsers will parallelize requests to a single host name up to 6 at a time. But if you use a different subdomain, even if it actually points to the same place, the browser will parallelize more 6 requests to that subdomain. So some people will use a separate subdomain for CSS, for window dressing widget images, and a different one for bigger photographic images and so on. I would just caution, on a home cable modem, that's probably great. You can probably speed it up. But for mobile users or slower DSL lines, you're probably just going to clog their pipe trying to fetch 12 or 18 requests at a time. So it probably has diminishing returns. And then it somewhat complicates your application too, having lots of sources of images. So that's something to experiment with. But my recommendation would be to start with just one subdomain, if any, and only add more if it's really proven useful. Doing your own CDN has some performance advantages. Adding new servers is cheap and easy if you have a way to get the data out there, or if they are using reverse proxying to fetch and cache it. My favorite one is it's possible to just do things really low budget. If you sign up for a dedicated server at any of the many providers out there, they're usually including something like 2 terabytes of inbound bandwidth per month per server. And you don't need much CPU. You don't need any fancy disks or anything, so $100 to $200 a month is enough for 2 terabytes, and you can't usually buy bandwidth that cheaply. So you can add servers of your own, do round-robin DNS if you don't have anything better to do, and you can get a lot of bandwidth for cheap for a project that doesn't have a big budget. So what's wrong with Apache? Because Apache can do all of that stuff too. Well, nothing's really wrong with it. It's just a little bit heavier in the pre-fork child model that is standard. Uses more memory, and in the pre-fork mode you need 1 process per client, so you just run out of resources faster. Nginx and Varnish typically use 1 process per core and serve lots and lots of simultaneous requests. There's a cute DOS program called Slowloris that will demonstrate how this the difference here. You can take out an Apache server very easily by just opening all of its connection slots and being very slow in how you make your request. And there's no more slots, so nobody else can make a request, even though there's tons of bandwidth, CPU, and all that. Nginx and Varnish handle that fine. And Slowloris is a fun tool to demonstrate this, but in reality you can have similar problems if you are serving lots of downloads, things that might take a long time and they keep a connection open for a long time. if you run out of slots, then you can't serve any more traffic. So, okay, even if you are just using Apache, some very basic stuff. If you're not doing this already, check your config. This is the easiest and cheapest kind of optimization to make. There actually are times where you may not want to use Keepalive, such as when Apache is the origin server behind a reverse proxy over a local fast gigabit connection. It can be faster to not do Keepalive because you want connections to open and close quickly. But when you're facing real public users, it's best to have Keepalive on, but with a short timeout, that's seconds, because you don't want people who aren't even using your site anymore to be tying up slots for too long. And then you want to have gzip or deflate compression on for anything textual, or if, heaven forbid, you're serving BMP graphics or PostScript files or things like that. Those are also compressible pretty well. Word documents, things like that could be added to this list, but these are the common ones. HTML, plain text, XML, should have application JSON on there too, actually. There's really, a few years ago, there were a few oddball clients that didn't work well with this, but claimed that they did. That was Netscape 4.0. I think we can safely ignore that. I haven't heard of a single one since. Internet Explorer 6 had a few goofy oddball cases, but I have not run into them for years. So,
Explorer 6 had some problems?
Well, a few. I mean, it's still a really, really good browser. So you may not want to do this in Apache if you have a CDN or a homegrown CDN of your own. Typically, they will cache each object differently depending on whether it was served compressed or not, and that increases your cache size quite a bit. So you may be better off letting your origin server Apache serve everything uncompressed to the edge, and they will do the compression or not depending on what the client requests. It would be, in my opinion, nice to see the cache be able to store the gzip one and uncompress it on demand for the few clients that need that, but I haven't actually seen that much. Varnish could probably be programmed to do it, but gzip is really fast, so it's not worth worrying about too much. So the tool that makes the browser know that it can cache a file without even checking with the HTTP server. In HTTP 1.1, it is the cache control header, and in 1.0 and Internet Explorer 6, it's the expires header. So what you need to do is convince your web server to, or your app server, it could do it too, to output these headers the way you want them to be, to say how long the client can trust that this hasn't changed. And everything in between the client and the server will believe you too, including reverse proxies. This is an example of what the headers would look like. This expires header I set at the time I wrote this, which I think was yesterday, 2 hours before or 2 hours after. This is 2 hours after when I calculated that with the expires header. So max age in the cache control is in seconds, so this is a 2-hour example. Now, let's say you want your intermediate caching proxies to store things for a much longer time because you have the keys to purge them whenever you want, so you can take greater risks. Well, this would be max age 7200 for any client, but S max age is for your proxies in between, and that's for 1 day. So you can have them be different numbers if you want. This is how to achieve that in Apache. I'll post the slides online, so if anyone wants to see that later, you can. Now, why am I using 2 hours? Webpagetest.org, which I love, and almost everyone else will say, oh, you should mark things to be cached for a week at least, maybe a month, maybe a year. And this is where I think reality diverges from the ideal. If you never use the same URL to represent more than one thing, that's wonderful advice. But for me, if I'm caching /, I don't want to cache that for a year, or anything I do wrong, I cannot make it go away from the clients, no matter what I do. So it's a risky game to play, and I think you're way better off doing something like 2 hours, 1 to 8 hours, because that's the amount of time where you go to sleep and you wake up and then you can start afresh, and your world is not in trouble because you messed up some CSS file and thousands of clients have it out there and they're not checking to see if you have a new one. So that's my advice. If you are Google or Yahoo or someone doing an awful lot of traffic, it's probably worth doing things a little differently. And I think you can live more dangerously with image assets if they have some kind of versioning in them or a name, and you have an easy way to make sure that those names stop being used in a few hours. But with a couple of hours, you can't shoot yourself in the foot too bad. And I should note, even caching something for 10 minutes might be enough for a lot of your users. How long are they on your site? I don't know, but it's probably not all day long for a week. If they're there for an hour, then your 1 hour cache lifetime is all you really need. And someone coming back 3 months from now who happens to still have that in their cache and they haven't browsed a lot and pushed it out of the cache, do you really care if you save them, 30, 50, 100 milliseconds? It's just trade-offs. Does anyone care about e-tags? Anyone want me to talk about that? I'm going to skip it then. App server caching. So now let's get below the web server level. Tried and true ways of caching stuff in an app server. Text fragments. You could have a left navigation bar or something like that was a pain to generate from a bunch of database queries. You can actually generate all the HTML, store it in a file, or under a certain key in memcached, and then just slurp in that text fragment, and that can speed things up. Did I mention if you cache the whole page, you don't have to worry about any of this? Yeah. The other thing is data. If you're using an object relational mapper or something, a lot of them will have a way built in for you to cache your programming language's objects so that you can do something with that data, and it may not be the same thing every time the way it has to be for a textual fragment cache. Don't forget, there's lots of things that are really helpful in development that you need to turn off when you go into production. Anything that checks to see if classes have changed, template files have new timestamps, anything that checks to see if your database schema is different, that's all going to be really slow. Most people would just laugh and say, oh, that's a mistake. You ran your app in development mode in production. But it happens, and if you're not using a framework, some of these helps may have been implemented ad hoc without anyone calling them development this or production that. So it's just something to check on. If you can get your app server to not write to the file system, that is a nice bonus because it means you can scale horizontally very nicely. If you're saving sessions to disk, then you can't just go add another server without figuring out some way to segment the visitors either by cookies or some sort of an IP address map in your load balancer or something. But if you store your sessions somewhere else that's central, or if you don't have sessions, or if you keep the sessions on the client, then you can just add new app servers at will, which is a really nice way to be able to scale. It also makes it possible to use cloud application hosting like Heroku and Google App Engine, which don't allow you to write to the file system at all because they decide which machine you're going to run on and how many instances and all that. This really, I suppose it excludes logging. You could keep logging locally, but if you're going to add more app servers, you might as well go to syslog or some other kind of centralized logging system so that you can be looking at aggregate data, and if one of your machines dies, you just don't care. Sessions. If you do use server-side sessions, try not to use them automatically. It's really convenient in your app server to have sessions just magically appear, but if you never use it and it gets read and deserialized and then reserialized and written and nothing ever changed, that's a lot of wasted time and energy. It also makes you never really sure if you can safely cache the whole page or not. So I work a lot with legacy applications where I just don't have the luxury of deciding this kind of stuff up front. But the first thing I try to do is figure out, is really anything on this page using the session that is there? If not, let's set a flag and say don't do sessions on this page. And suddenly you've marked out a space where you can do lots of optimization. Not using sessions at all is, of course, great, but that may be too much to ask. Try using HTML5 local storage or cookies. The great thing with local storage, again, is you're not sending the data to the server all the time. It just stays on the client. Maybe you can make that work. If you're working with modern web frameworks, then you're going to have a lot of options here. Read around to see what people do as good practices. You probably don't need to reinvent the wheel. Before you spend time optimizing anything, even full page caching, find out which pages get visited. Because if there's some obscure page that only gets visited a couple of times a day, no matter how fast you make that, it doesn't really matter. So, it's a safe bet that your / page matters. But beyond that, how much do the others matter? Pick the ones that matter. Instrument your application. Find out which database classes are getting used a lot. And that may be what you want to cache. Find out which pages get hit a lot. Find out what the percentage is between unauthenticated users and logged in users to know what to attack first. So database optimization. I'm not going to go into a lot of detail here. It's really its own subject, and this is even lower down the stack, so I'd encourage you to not do this unless you have a good reason to. But having said that, it's a lot of fun to take a really bog-slow database query that is taking 7 or 8 seconds and get it down to sub-second. So, do it if you need to. You can do that by tuning the query. Possibly there's an ORM, object relational mapper, involved that's doing some really dumb, lengthy, multiple joins. Possibly your object relational mapper is bringing back a lot of data to the application, and then the application is weeding out data it doesn't need there. Maybe you need to override that particular class in your object relational mapper and write a custom SQL query. Maybe you just need a few indexes that are missing for cases that you're selecting on. In some cases, maybe you have indexes you don't need, which won't slow down your reads, but it will slow down your writes and waste disk space. So there are ways to check whether an index gets used at all. I use Postgres mostly. You can check to see if an index is unused and then just drop it, assuming it's not being used for a constraint or some other functional purpose. And then there's sharding. If your data model isn't, either if it has islands of separateness or if it isn't very relational, you're not using foreign key constraints and all that, you may be able to shard it in easy, lazy ways. You can probably shard it sanely too, but I say under duress because I would avoid that if possible. It changes your app quite a bit. But there are tools to help you with it if you need to do it. Slow queries, MySQL, for example, has a way to log slow queries separately. That's popular and awesome. Check it out. But don't forget that lots and lots of really fast queries may actually be what's making your system slow or holding locks that are blocking writes, things like that. So find a log analysis tool that will weight the queries. If you have one really slow query, but it only runs twice a day, probably you don't care if no customer's waiting on it. But if you're hitting the same thing over and over, that could actually be your problem. Remember, things don't stay the same. So when you launched a new feature 2 months ago and there were only a few thousand rows in a few tables of interest, you may not have had a problem. But in the meantime, you may need some indexes where you didn't have them before because a full table scan's gotten prohibitively slow. you may find that things you were doing don't make sense with a lot of data. So go back and check on that. And counterintuitively, every once in a while you'll find out someone deletes a lot of data and something that was really fast becomes slow because the query has just been pessimized somehow. So that can happen too. That's a little preaching again. So kind of to summarize in reverse order. It's great if you don't have to spend much time tuning on your database. It's great if you don't have server-side sessions or don't use them much, so that's never a scalability problem. It's great if your app server's bored because so many of your pages are cached at the edge. It's great if your main web server is even bored because some CDN is handling the traffic, especially a free one like Google serving some of your assets. And it's great if the CDN is bored because repeat visitors already have the data they need in their browser, or at least a good chunk of it. And it's great if users come and they've already loaded up jQuery from visiting some other site. So having said all this, there's a lot of things, and I feel like I'm rushing through it, but boot camp is supposed to be kind of painful, right? And don't try to do everything here. Look at the things that are the lowest risk for you, especially the time when it makes the most sense to worry about optimization is when you have a thriving, busy production app. But that's also the time when people least want to let you do something like that without advance proof that nothing will go wrong, and that it won't take you very long, and that there are no trade-offs like more stale data getting out there. So measure and do what you can. To go back to this web page test thing, and hopefully to hearten people a little if you haven't done much of this, this was a pretty naive site originally. It didn't specify any cache control headers. It had HTTP Keepalives turned off. It was not using gzip. And you can see the Fs up here for that stuff. And then just by doing 15 minutes of work in Apache and a little bit of testing, that repeat view time is way, way, way faster, and it's using a lot less data. So this was done, if I remember right, we did this the day before. We had a one-day notice that this site, which is hosted on a little VPS, was going to get slammed by some sort of big promotion. And there's really not a lot you can safely do with a little amount of time. But you might as well serve less data. You might as well cache some things. So that helps. By the way, this F on cache static content is just wrong. There used to be a bug in web page test, and it affected IE. I think somehow that they were measuring it didn't work right. But if you looked at the waterfall, there in the repeat view, there's just almost nothing being served. So the cache was working there. Anyway, double check everything, and don't be scared about these grades. CDN detected. For many small sites, do I care that there's no CDN? No, of course I don't care about that at all. So don't, take everyone's advice with a grain of salt. It's like the caching. I felt for a while like I was missing something. I should cache for a whole year, and it just sounded insane to me. And I realized, yes, it is for my situation insane. So I'm just going to stick with that. Another nice thing to do is if you feel that there's not a lot of tolerance for risk, make a few changes and do just that and sit on it for a couple of weeks. And then if the site falls apart and it was your fault, you know where to look because you didn't change too many things. If the site falls apart and it wasn't your fault, you will probably be able to figure that out faster and figure out what actually happened to change at the same time, unfortunately. And then you can regain the business folks' trust that it's safe to keep doing optimizations later because that wasn't the problem. So a few oddball things to share that might be of use to somebody. One time we had a customer, their site was relatively well optimized, but they were featured on the Today Show, and that meant that their URL was read aloud, and there were a couple of funny things about this. One was their URL was read without the www. And in their case, the www was canonical, so there was an extra redirect for every single visitor who hand-typed it in on their iPad or phone or laptop or whatever while they were watching TV. So that added a lot of extra traffic. The other problem was, at the time, Omniture Test and Target had a test running, and so 50% of the people, after they made it past that first redirect, then got redirected to some other page. That was humorous. Well, actually, none of that is what brought their site down. And the site being slow didn't bring the site down. What brought it down was IP tables. We had a common state tracking rule that only allowed traffic other than, say, to public services like port 80 and port 443. It only allowed traffic in from existing connections. And their state table just filled up. And so the server was bored, Apache was bored, CPU was just sitting there, but you could barely get a word in edgewise. If you had an existing SSH connection, you could get in. If you didn't, you might be sitting around waiting a while for a state table entry to free up. I saw the same thing happen with a different customer that had an OpenBSD firewall at the edge of their network, and the PF state tables filled up, and their internal machines and were serving traffic just fine. It wasn't even close to out of bandwidth, but really dumb. You can increase the size of the state tables. That's what they did. With this other one, with IP tables on Linux, we just realized, I think we can get away with it on this server. We don't need to track state at all. So if you get rid of all the rules that use state and restart IP tables, then it never loads contract, the module that does that, and you never run into the problem. Esoteric, weird thing. It took me way too long to figure that out, so hopefully that'll help someone. Then there's DNS problems. Anywhere you have logging, you may accidentally have something doing reverse lookups, either in real time, which is of course the worst, or after the fact. You may have forward lookups. Say you have an app server talking to a database server. I don't necessarily recommend you hard code the IP address there, although that will keep this from happening. But you could have had something in etc hosts that someone helpfully removed, and now you're doing DNS lookups for lots and lots of traffic you weren't doing it for before. So if your server side is slow and you don't know why, and it seems recent and it doesn't seem to correlate with increased traffic, start logging all of your traffic. Use the great tools that are out there. Put your interface in promiscuous mode and start logging packets and seeing what's all this DNS lookups for this thing that shouldn't be getting looked up. And check what's getting logged. Sometimes on a really high traffic site, you may have the mere act of logging to disk burning through so much I/O, or logging to syslog, clogging up your network, and you may just need to dial it back, do log sampling where you only send 1 out of 10 or 100 log entries, or turn it off, or some kind of a batch process, or send it over a different interface, or something like that. The impossible often isn't, both in the bad sense that something that never could possibly do this problem is, but also solutions that people think won't work might. For me, full page caching, when I started doing that several years ago, it just seemed like the unachievable dream because I was dealing with so many legacy applications that weren't designed for it. But it is possible. You can get there, so try. Sometimes it's too hard and you've got to give up, but sometimes it works. This is a list of tools. Webpagetest.org is a service I mentioned. I like it because it's on IE, but another good reason is it creates permalinks for all those results. That's really nice to share with business people, with other developers. And that one I showed you, it's still there from 2 years ago. I mean, that's an old one. So that's really nice. Obviously, it could go away, but it's been there for a while. Google PageSpeed is another service that's nice. Chrome Developer Tools. YSlow are both nice things for your browser that can show you that same kind of waterfall, time things. And then Yahoo's performance rules, that's an explanation of a lot of these things in greater detail. There's really a lot out there, but these are some of the best ones, I think. So, got a few minutes left, so be happy to hear any questions. Yeah.
I have on any of your projects, have you used any of the term escape my mind, the NoSQL databases?
I am not on any projects I'm working on now. We've used Cassandra for a couple of things, and a few of my coworkers have used MongoDB, but not for the purpose of optimization, really. So, anyone else? Come on, isn't anyone going to argue with me about sharding or something? That's so cool. Come on. Everybody has to shard. Or indexes? You can never have too many indexes.
I just mentioned that as far as tools go for testing that, there's another site called gtmetrics.com with an X, and that does the Google PageSpeed and the YSlow and gives you the history as well.
Cool. Nice. Thanks. One thing I'd mention too, if you're playing around with this for the first time, I think it's kind of nice to learn how to talk straight HTTP and test things out by hand. Like if you want to see if your gzip and deflate is really working, well, one way is to hand type your own GET request that says accept encoding : gzip, deflate, and see what you get back. You know, obviously you can sniff the wire or use an intermediate proxy to see what came through the wire, but kind of nice to know how to do it by hand, you know. Yeah?
Another comment along the same lines. I found that sometimes when we have 404 handlers that handle redirects and things like that, you'll get responses back from search engines like Google indicating that you're sending a 404 when you're really sending a 200. And if you test it out from the command line, you'll find things like you get the 200 and the page, and then you get a 404 after the end, but your browser will chop it off because the length is already determined. But if you run those kinds of things from the command line like you're saying, you'll get the whole response and you'll be able to find the problem.
Yeah, good point. And on a related note, if you're going to use custom handlers for 404s, 500s, anything like that, make sure they're lightweight, or possibly can be carved off to run on another machine, because you feel really dumb, and I've done it several times, to have a 404 page doing a lot of database intensive stuff, and then somebody in content side changes things, and suddenly you have lots of 404s you weren't having yesterday, but normally you think those are harmless, right? So side effects.
I know it has some downtime, it's very frustrating, but Cloudflare is really easy.
Yeah, I gave up on that. I tried it, and it was so flaky at first. I probably should try it again, though. Who does that? Isn't that Amazon or somebody? Or is it independent? Cloudflare, though, yeah, I should try it again. It's a free CDN, right?
Yeah.
So. And I think it tries to do geographic distribution too, right?
How does a free CDN work? You're not serving ads overlaid on your JPEG.
Volume. No, I don't know. It looked to me like a business model that was going to be based off the analytics, and maybe, hopefully, we'll figure out how to monetize this someday. But I'm not the best one to ask, though. I haven't looked at it recently. So, do you know?
Well, you pay for premium for service.
They do.
Makes setting up certificates easy, but
do they allow SSL on their free service? Maybe that's one of the things.
No.
Oh, another performance thing I forgot to mention. I don't have the details, so this would only matter if you think it might matter, but some SSL ciphers are slower to negotiate than others. I think ephemeral Diffie-Hellman, EDH, in OpenSSL talk is particularly slow. There was a blog post a few months ago. A guy said that Nginx's SSL was just bog slow compared to Apache's. And it turned out it was because he had a different OpenSSL configuration, and it was preferring EDH, and it's just way slower to negotiate the connection. So you might want to check, if you're doing a lot of SSL or TLS traffic, check on which ciphers you're using or benchmark them. And even if you allow the slower ones, you might want to prefer the faster ones.
Other things of interest, Google's new Speedy protocol.
Yeah.
Under Beta, Apache, Mob, Speedy. And then with WordPress and Drupal, which is probably something a lot of people are using here for small sites and big sites, you can have all the static stuff automatically pushed to a CDN.
Oh, yeah? Cool. Are there plugins for that do it? On the Speedy thing, I heard that Nginx is supposed to support that in next month, something like that, in beta form, so that'll be neat too. Any other comments or questions? Thanks for the input too. You're bringing up good stuff that I didn't mention. All right, thank you very much.